A pin feels sharp. A silk cloth feels smooth, while ice feels cold. You know what all these things feel like because of the free nerve endings in your skin. These free nerve endings spread in the dermis layer of the skin, making it the largest sense organ. Did you know that there are different nerve endings or receptor corpuscles for various sensations? For instance, the tactile receptors are for touch, pressure and vibrations, while the thermoreceptors are for temperature and the nociceptors are for pain. The touch or tactile receptors on your skin are also called tangoreceptors and are further classified into 6 types. These are free nerve endings, root hair plexus, Merkel's discs, Meissner's corpuscles, Purkinje's corpuscles, and Ruffini corpuscles. The free nerve endings are situated between epidermal cells and are sensitive to both touch and pressure. The root hair plexus is made up of free nerve endings to detect touch and hair movement. Merkel's discs are located in the lower epidermal layer of the glabrous or hairless skin. These receptors respond to fine touch and pressure. Meissner's corpuscles are sensitive to light, touch and vibrations. These are located in the eyelids, lips, fingertips, nipples and external genitalia. The large receptors located in external genitalia are the Purkinje corpuscles. These receptors are sensitive to deep pressure and high-frequency vibrations. Apart from external genitalia, they are also found in the fingers and breasts. Ruffini corpuscles are located deep in the dermis and are sensitive to pressure and distortions of the skin. Interestingly, some tactile receptors, like the free nerve endings, Meissner's corpuscles, Merkel's discs and root hair plexus, have a property called adaptation. This property is seen when the receptors respond to a stimulus, and if the same stimulus is applied continuously, the receptors no longer respond to it. For instance, after wearing earrings, you don't feel them even though they constantly touch your body. In addition to tactile receptors, there are heat and cold receptors, known as thermoreceptors, which are widely distributed in the skin. These receptors respond to the changes in the temperature. As the name suggests, cold receptors, also called frigidoreceptors, respond to low temperatures ranging from 10 degrees Celsius to 20 degrees Celsius. For instance, the cold receptors are stimulated in a person working in an air-conditioned room. On the other hand, the heat receptors, also called caloreceptors, respond to high temperatures ranging from 25 degrees Celsius to 40 degrees Celsius. For instance, the heat receptors are stimulated in a person working in the sun. There is no structural difference between cold and heat receptors. However, the number of cold receptors is 3 to 4 times more than that of the heat receptors. Besides all these receptors, there are free nerve endings below the surface of the skin, which respond to pain caused by touch, temperature, pressure, and chemicals. Such receptors are called nociceptors. These receptors produce fast pain as felt during a prickling sensation, or slow pain as felt during an ache or a burn. Nociceptors warn you about dangers. This is why you don't touch sharp or hot objects, as they hurt and may be even dangerous to you. All the skin receptors, that is, nociceptors, thermoreceptors, and tactile receptors, are collectively called cutaneous receptors and are widely distributed throughout the body. However, their distribution is uneven. They are more concentrated on the cheeks, lips, and fingertips. Incidentally, the intensity of feeling a stimulus depends on the area of your skin. For instance, if a pin or thorn pricked your fingertip or heel, the intensity of the pain would be more in your finger than in your heel. This is because the epidermis is thicker in the heel than in the finger. Moreover, in the fingers, the free nerve endings are closely arranged and are sensitive to very weak stimulus, making the fingers good feelers. This explains why you can tell the shape and texture of an object even with your eyes closed, simply by touching it. Therefore, the visually impaired use their fingers to read and write in the Braille system, in which the letters are in the form of elevations and depressions. However, your skin does not function alone. It works in coordination with the brain and the spinal cord. When a receptor is stimulated by a stimulus, it generates an electrical impulse which travels to the brain via the spinal cord. The brain analyzes and processes the stimulus, and the body reacts accordingly. The presence of skin receptors, thus, helps you feel various sensations like touch, temperature, pressure, vibrations, and pain.